So if I asked you to simplify this and leave your answer in factored form, we know from multiplying and dividing, it is sometimes helpful to simplify things first, check if anything factors. That can be helpful here still. However, you really don't need to factor the numerator when you're adding and subtracting. We just really need to factor the denominator. Because what do we have to have if we're going to add two fractions together? The common denominator. We need the same thing on the bottom. And you don't want it to be more complicated than it has to be, so we want that bottom factored so we can figure out exactly what we need to make them identical. However, in this case, I have a typo. That should be a negative right there. These denominators are already the same. Now, what does this off to the side, x cannot equal negative 5 halves? What is that? Yeah, that's the domain, like we talked about yesterday. It has no bearing on how we proceed with this problem, but you should get used to seeing it. ACT, things like that, they like to include extra pieces. The domain is sometimes important. It's really not here, but when you see those questions on the ACT, it's probably going to have that stuff just to try to confuse you. Okay, so really we just ignore that. It's not going to change anything. So if I want to add two fractions, the denominators have to match. That's the bottom of the fraction. I look and these are identical, so we can put them together. When you put them together, the denominator does not change. Then we just add the tops together. So we combine any like terms, so I have a 2x squared. I have a plus x. Negative 4 plus 3 would be a negative 1. Does everybody see where I got that? At the end, we do still want to make sure our fractions are in lowest terms, so I'm typically not going to tell you have to factor out the numerator or anything like that, but if there was something that obviously canceled, I would expect you to reduce that at that point. Let's try another one. So this one was nice, denominators already matched, so we can just add them. Bless you. What is the domain this time, if I ask that question? What can P not equal?
Negative 5, no.
We know that in a fraction, the bottom can't be 0, right? Yeah, P can't be 0, would be the domain. Same thing with the 4P. Either way, both of those, P can't be 0. So that's just kind of a side note relating to yesterday, our domain on that. Now, in order to add them, the denominators need to match. Okay. When I look at this, they both have the P, but 5 and 4 are not the same coefficient. So what could I turn both of those into? 20. Right? So 5 times what gives you 20? And if you multiply by it on the bottom, you have to multiply on the top. Okay, this one, what does it mean? 5. So I'm going to multiply by 5 on top and bottom. So I get 32 over 20p plus 15 over 20p. Now my denominators are the same, so we can put these together. 32 plus 15, 47. 47 over 20, does that reduce? No, so we're done. Reduce if you can, but otherwise we're finished. Let's try another one. Alright, are these denominators the same? No. What's the difference?
Just a negative, isn't it?
So we can change either one of them just by multiplying by a negative 1. So let's say I want to change this one. So I'm going to multiply top and bottom by negative 1. Because you can't change the problem, so whatever you do on the bottom, you have to do on the top. So this is still 2x for x minus 3 plus negative 5. That would turn into a negative 3 plus x, which is the same as x minus 3. So I can put these together. And on the top I have 2x plus negative 5 or minus 5. Let's try this. So do my denominators match? No. They are factored, so that sets me up to get a common denominator. If I look, the first one has x minus 3 and x plus 5. What does the second one have that we're missing? Yeah, x minus 5. So I'm going to multiply top and bottom by x minus 5. So if I look at this one, it has the minus 5 and the plus 5. What does it mean? We have to multiply by x minus 3, the entire factor, the entire parenthesis. I want to leave my denominator factored. You can multiply it out, but it just takes a lot of time and it's really not necessary. But the top we do need to multiply, because I want to be able to add and subtract like terms. So 4 times x will give me a 4x minus 4 times 5 is 20. Second, let's see, we have the same denominator. On the top, if I distribute the 6, it gives me a 6x minus 18. Because I am subtracting, what do I need to do? What do I need to do with the subtraction? I'm going to make this plus, and I'll take a negative through here. So then, adding together, denominator does not change. 4x plus negative 6x would be negative 2x. Negative 20 plus 18 is negative 2. If you wanted to factor a negative 2 out of the top, that's fine, and have negative 2 parentheses x plus 1. Just another way of writing the same answer. You guys aren't complaining. Usually when I teach this, I get a lot of grumbling. Are we doing okay with it? Did you do any of this last year? So my denominators don't match. I'm just going to rewrite this problem because I need more space. So what do we need in order to make them match? What are we going to have to multiply by? Good. You can't just multiply by the 4 or the negative 2. You have to do the entire factor here. So this needs an x minus 2. And this needs x plus 4. Denominator we want to leave in factored form just to make life easy. The top though we do have to distribute, so I have to FOIL those. So we get x squared minus 2x and minus 3x would be minus 5x plus 6. This one we would get x squared plus 4x. So now put them together. Combine like terms, so x squared plus x squared would be 2x squared. Negative 5x plus 4x is negative x plus 6. We ready for a more challenging one? Let's go to this one. How do we have to begin to get our common denominator? Factor the denominator. So this one we can take out x. We have x plus 1 remaining. This one, multiply to 1 and add to 2. Alright. So for the common denominator, this one has a plain x and 1 x plus 1. But to match the other one, we need 2 of those. So it needs another x plus 1. This one has both of the x plus 1s. What does it mean? Do you guys care if I write the denominator as x plus 1 squared? So if I distribute my 3, we get 3x plus 3. This one, we distribute the x, so we get x squared plus 4x. But what do we have to watch? Negative. So I'm going to change this to a positive. Distribute that negative. On top we have a negative x squared, 3x and negative 4x is negative x plus 3. If you have the terms in a different order on top, that's fine. Order doesn't matter, I just typically put them in decreasing order. I want to give you guys one of these to try, and if we do okay with that, then we're going to move on to the last type of problem in this section. the denominators first. Multiply 2 and add to 3. Be 2 and 1. X squared minus 1, how does that factor? Difference of squares. So we need these things to match identically. This one has an x plus 2 and an x plus 1. What is it missing? This has the x plus 1 and minus 1. It needs x plus 2. So if we distribute on the top, we get x squared minus x. This one we have to FOIL, so we get 2x squared plus 4x and minus 3x is plus x minus 6. Are you okay to this point? Now the denominators match, so we can put this together. So x squared plus 2x squared would be a 3x squared. Negative x and positive x cancel, minus 6. And if you wanted to factor that, you could take a 3 out. It would just be 3 and then parentheses x squared minus 2. And then that would be as far as you could go. So I know there were a couple errors on that, but it looked like you guys had the process down. Are you okay if I go ahead and do the last type, and that way you can work and ask questions if you get stuck on something? So the last thing we are doing in here is simplifying what are called complex fractions. That's a fraction and a fraction. So this is a pretty nasty looking problem. There is more than one way to solve it. If you have a fraction divided by a fraction, we know we can flip and multiply. In order to do that, we would have to first get a common denominator with those two and put them together into a single fraction. And then we could flip and multiply. So it'd be basically 2 steps. Common denominator, flip and multiply. The other option is kind of a shortcut that has to do with trying to get rid of the fractions to start with. So I would look at all of my denominators and say, okay, I have a 2, an x, and a 4. What could you multiply by that would cancel out all of those things? A 4x. So we could take everything times 4x and clean it up a lot from there. Do you guys care which process? Okay, let's try the second one. So 2 and 4, we know if I multiply by 4, that would cancel both of those. And since we have an x, we need an x. So I'm taking the numerator and denominator of this big fraction times a 4x. Now we distribute that. So 1/2 times 4x, 2x. 3 divided by x times 4x. If we did that, 3 divided by 4, 3 divided by x times 4x. What happens to my x's? And you have 3 times 4, which is what? On the bottom. These 4's cancel. so I have x times that x plus 3. Turn into x squared plus 3x. Did I lose anybody on that? Let's add one more. Okay, this is on last examples. So if I'm looking at this, kind of messy because of the fraction and a fraction. If I look, my denominator here is an x, and there is an x. So easiest option would just be multiply everything by x. So if we distribute, 1 times x is x, plus, what's 1 over x times x? Okay, 1 times x is x, minus 1 over x times x. So x plus 1 over x minus 1. Alright. Any questions on that? So at this point, you have the rest of the hour to work on that Math Excel assignment. It is due tomorrow. Remember, we have Quiz Friday, so tomorrow we're just going to be reviewing all the different things we've been doing.